Hello, everyone. I'm Jordan Leach, and I'm a software engineering director at FanDuel. And with me, I have Alex Chadwick, who's one of our brilliant staff engineers. And today, we're here to talk to you about how we're using CockroachDB to scale to meet America's #1 sportsbook. And as many of you know, at FanDuel, we have our flagship product with the FanDuel Sportsbook. But in addition to that, we also have a myriad of other products, including FanDuel Casino, FanDuel Fantasy, FanDuel Racing, Face Off, Free to Play. We also have a variety of retail locations for our sportsbook across the country, in addition to our own TV station, FanDuel TV, and our most recently launched product of FanDuel Picks, which allows customers to predict whether or not their favorite players are going to beat their projected stats. And with that, an important part of having all of these different products is we want customers to have the ability to just log into one single account and have a single wallet that they can then access to play with their funds in these different products. And so with that, we've built a financial ledger system that's required for tracking every financial transaction that happens between a customer and FanDuel. And as well, it's responsible for tracking all of their individual balances. And this single shared wallet allows us to then give them the ability to use their funds across these different products how they may see fit. But with that, there's some exciting scaling challenges that come with it. So where is FanDuel Sportsbook and Casino? Today, FanDuel Sportsbook is live in 27 online states, including Puerto Rico, and we'll be launching the state of Missouri in early December. In addition to that, we have 5 casino states of West Virginia, New Jersey, Pennsylvania, Michigan, and Connecticut. And as many of you may know, these are highly regulated industries. And so as a part of that, we work with AWS and run 28 independent AWS outposts that support these ledger systems, where we have an instance of the service as well as a database that support the service to record all of those transactions. And so from here, I'm going to hand it over to Alex to talk to you a little bit about our Percona solution and how we've architected that today.
Nice. Cool. So yeah, as Jordan was just saying, the database and its application have to exist in the location where the user is for our service. And that introduces the funnest kind of requirement for all of this. Because AWS and their regions only exist in, 4 US states physically. So what are we doing for the rest? This leaves us with things like AWS outposts. And if you don't know what they are, you can think of it as AWS hardware in a non-AWS data center with kind of limited functionality and services. And we also use AWS local zones. And you can kind of almost think of that as an AWS managed kind of set of outposts. But that introduces all kinds of fun issues for us. And the biggest one by far is there is no managed database service worth using at all. There's no Aurora cluster company save you. There is RDS kind of as a service, but its high availability options within a single site are pretty poor. The second major concern is there are no network load balancers. So you want to think about how you're going to manage your database kind of connections there as well. And there's other just fun hardware constraints. So these are physical racks deployed into data centers. We're back to sharing compute and storage and thinking about how we're allocating resources as well. So super quickly, in the diagram, you can see a summary of the application. At the top, the ledger service, and right down the bottom, you can see the Percona XtraDB cluster. So this is 3 EC2 instances. This is Percona's solution for MySQL Galera. So this is our existing kind of pre-Cockroach setup. And you can see the ledger application connects to Proxy SQL, which is distributing its connections down to MySQL. And that is doing things like a read-write split, because that's necessary. Oh, of course. This is the part where I stare at this lovingly. This worked for years. This really worked. It saw us with some pretty tough spots. And it's also really simple, relatively pretty damn simple. It's well understood by the developers. You can pretty much just think of this as MySQL. It's also cheap as chips. It's virtually synchronous. We get this data consistency guarantee, which is super important when we consider things like automatically failing over this dedicated writer in the setup. But as FanDuels continue to scale, the cons of this setup start to become more and more important, more limiting. And the first one right away is it's virtually synchronous. We just mentioned this, wonderful for consistency, not so fantastic for write latency. We're also looking here at the scaling limitations. So we can really only vertically scale writes in this setup. For our setup, when we tested this, adding more writers to the mix resulted in higher write latency as you get these kind of certification issues. And also we just run into the standard MySQL pains. You've got some massive tables. Congratulations, your schema changes just got interesting. And other fun stuff. And DR is worth talking about as well. So if you lose 2 nodes in this PXE cluster, congratulations, you have to bootstrap that manually now. Be careful. Cool. So FanDuel is scaling. That takes us right back to Jordan.
Yep. So why CockroachDB? Starting at the beginning of the last year, we started doing some projections internally and taking a look at where our business could be in the next 2, 3, 5 years. And 2 things stuck out to us is 1, the potential of New York legalizing an online casino, where we would expect that to project about 1.8x times the scale of Michigan, as well as the opportunity for California to legalize its own sportsbook, which almost happened in 2024, and that being approximately 2 times the size of the state of New York. And so we're talking very rapid growth, very quickly. And the last thing we want to have to do from a technology perspective is tell our business, oh, you can't launch this product because one of our core systems can't support the traffic. And so based on where we were at, what we started looking is saying, okay, if none of this happens, where would we at? Where would we be good in the next 2 to 3 years? And we'd be okay. However, if even just one of these big bets hits, that's where we really start to get in trouble. And for us, that's where we said, okay, we need to start this journey now because we can't wait till those legalization conversations even start to happen, because at that point, it's probably going to be too late. And so this is where we came to CockroachDB. And we started last summer doing a POC, and with our existing Percona solution that Alex just talked through, we were able to hit approximately 2,700 transactions per second with some decent latency. From there, once our engineers got their hands on CockroachDB, we started really seeing its potential. And first and foremost, the biggest potential was that ability to horizontally scale. In the past, we were stuck with vertical scaling, and horizontal scaling wasn't necessarily something we could do. In addition to that, though, we also looked at, okay, how do we actually need to change our ledger system to adapt to use Cockroach rather than just trying to shoehorn and replace Percona directly? And so that's where we looked at making changes like modifying our primary keys for some of those core tables, as well as removing sequential IDs that were creating hotspots within the Cockroach nodes themselves. And through that testing and our own POCs, we were able to get, with 9 nodes, over 3,300 transactions per second and very similar latency metrics. But our engineers didn't stop there. They kept going. Their goal was, okay, how do we go even further in that? And that's where the 4x scale conversation started to start. And for us, it was, okay, hey, we've got some of these features that we've built, and we need to look at how does Cockroach handle these for us. And so the first one was change data capture. And so we had our own custom event framework that we were building and maintaining ourselves. And we sort of said, okay, let's swap that out for change data capture and see what the benefits are there. In addition to that, we took advantage of time to live, which allows us to archive and clean up transactions that are old and we no longer need to store in that database. So then storage concerns don't become as big of a concern day to day for us. And lastly, using what Alex talked about and being able to actually change some of our old indexes using Cockroach was another huge win. And so after making these changes, now we have full confidence that even with the same 9-node structure, we could hit well over 5,000 transactions per second. And if we were to continue to add more nodes, that's where 4x is definitely something that's achievable for us. From here, Alex is going to tell you about our path to Cockroach, as well as how we've set up the infrastructure between our ledger system and Cockroach today.
Cool. So we're going to talk really quickly about the migration. And that's because it's not too interesting. Super simple. We went the lazy route. We're using DMS. It's kind of magical, kind of simple. You take your MySQL, it does a translation into something Cockroach appropriate, and it's also incorporating those schema changes that Jordan mentioned, which help us kind of unlock that kind of additional performance. But there is a slightly interesting bit here. So we needed to consider a potential migration outcome where we have to fail back. And this is not something that DMS supported, but luckily the lovely people at Cockroach were able to help us use their tool, Malt, migrate off legacy technology, to do something very similar. So reading in the kind of CDC and writing to MySQL. And that was it very quickly for the migration. And this is kind of us now. This is us post MySQL. Same kind of diagram again on the left-hand side. You've got the ledger service right at the top, and right down the bottom, you've got all the CockroachDB nodes. The big thing to note is no more proxy SQL, and that's because we can use HA proxy here to do a much simpler job. It's not doing read-write splits, not doing anything complicated. We're just making sure it's spreading out the load, which is a nice simplified kind of use case. And this is us kind of looking at a single site here. It's worth pointing out that we're not using Kubernetes. We've just kept these nodes on EC2. And that vastly simplified our migration, keeping like for like where it made sense. So our setup here is just Packer and Ansible to generate the AMIs, and then we merge the instances through an ASG, which is sweet. It keeps those EC2 instances kind of almost ephemeral. We're kind of getting the best of both worlds in some regards. And that's mostly possible due to kind of two key factors. So we're using the HA proxy service discovery API. This is continuously updating HA proxy's backends using things like tags on the EC2 instances as Cockroach nodes are added and destroyed. And we're also reusing the EBS volumes, which contain the persistent CockroachDB data. So they have a very different life cycle from the EC2 instances themselves. An instance is terminated, the ASG spins up a new one to replace it. That instance has no data volume initially, but it's able to discover available free ones using their tags. It will attach it, mount it, start the Cockroach service, and at that point, from the cluster's perspective, it's like that original terminated node is back in action and ready to go. And that makes things like re-rolling your entire cluster simpler and kind of quicker. Cool, and let's zoom out a little bit. We were looking there at one single site. But part of the value of Cockroach is that it allows us to kind of get some of this DR a bit easier. So right down the bottom, you can see two sites, one in Outpost, one in the local zone. These are in the US state. These have the application, but we can go a little bit further as well. So we've got some nodes in the same Cockroach cluster now running in the AWS region. There's no application connecting to that directly, but it allows us to offload some fun tasks as well. So operational things like doing your backups close to your storage, which was handy. We're also doing things like allowing just-in-time kind of ad hoc user access to the databases here as well. So using stuff like HashiCorp Vault to create temporary user credentials based on the staff members kind of group, the level of access they should have, and that will exist for a small period of time, return some credentials to them. And the biggest kind of value add we get from that is it all ties into the CockroachDB audit log, and you end up with statements which are linked to individually identifiable humans with the level of access they had. It's the kind of thing that makes your change management team really happy. And that is me.
So again, why CockroachDB? And there's kind of four key themes that we found at FanDuel. First is that ability to scale up and scale out, which is most important for us as we continue to try and stay ahead of where our business is going and the projected traffic that we can see. In addition to that, the ability to take advantage of some built-in features to CockroachDB, like change data capture and time to live, as well as that built-in audit logging that, like Alex said, makes our change management folks and compliance partners very, very happy. And lastly, the faster schema changes. And so now in the future, if we want to continue to iterate on our ledger databases and the schemas that we have, we're not afraid of just taking the entire cluster down or not even be able to make those changes and what it would mean to actually modify our database going forward. And finally, I want to say thank you to the engineers at FanDuel that made this happen, one of which Kevin is sitting in the audience today. But in addition to that, we had an entire team, Matthew, Graham, Morgan, Josh, Dan, Pat, and Alex, of course, who without that, I wouldn't get to come to Vegas and present on CockroachDB and talk with all of you lovely folks. So thank you.